Lesson 7.2, Graphing Polynomial Functions. Now it says here that we are to graph this function making a table of values. But before we do so, let's consider what we already know. We know that we have the y-intercept of 5, we know that the function is a degree 3 function, which means that it will either open up like this or like this. We will describe the end behaviors as, in the first case, as x goes to negative infinity, our y or our function goes to negative infinity. As x goes to positive infinity, the function goes to positive infinity. In this one, as x goes to negative infinity, the function goes to positive infinity. And as x goes to positive infinity, the function goes to negative infinity. We have a negative sign in front for our lead coefficient. And see if I'm right. I believe that when it is that way, it will look like the second function graphed there. It's positive. It looks like the first one. So let's see what that looks like. I recommend that you use a graphing calculator with this to come up with a table. It's good to get used to it. And since we have the technology, let's make the most of it. If I go to y equals, and I plug in that function, which would be negative x to the third power minus 4x squared plus 5, and I graph it, the function would look like that. Now that's just a quick reference. Let's go to our table, second function graph, and take a look at our values. Notice that when I go to negative 5, I'm up to 30 already. Well, I can't graph that. That's pretty high. If I go to negative 4, it's at 5, and so on. Those are pretty decent numbers to use. If I go past 1, I'm at negative 19, so it drops pretty fast. So let's use that information to graph what we have. We have a negative 4 giving you a 5, negative 3 giving you a negative 4, and so on. Just copying down the graph given to us, or the table given to us by the graphing calculator. Okay, one quick check to make sure it looks all right. I think I got it all right. We graph these points. We have negative 4 and 5, negative 3 and negative 4, negative 2 and negative 3, negative 1 and 2, 0 and 5. That's what we thought our y-intercept was going to be, and we're right. 1 and 0, and then negative 2 and negative 19. That's pretty far below. So we have a rough the best I can draw with what I have in my hand here. And that's kind of what we talked about. It does open up what we discussed because it has a negative leading coefficient. Next one, determine consecutive values of x between which each real zero of the function is located. Then draw the graph. Now again, if we use our calculator, we plug that in. We have x to the fourth minus x squared, or excuse me, x cubed minus 4x squared plus 1. Now again, before I graph this, let's just write down what we know. We have a y-intercept of positive 1. We have a degree 4 function, which means that it would look like that or that. And since it's positive, we'll say it's the first one. Now it would be the negative one. Alright, let's take a look at our graphing calculator and graph it. And that is what we were thinking about. Y-intercept looks like it's at positive 1 and positive lead coefficient, so it opens upward. Very good. If we look at that function on our graph, we notice that it intersects the x-axis between, looks like, negative 1 and negative 2, and then between 0 and negative 1, and between 0 and positive 1, and it looks like between 2 and 3. That's an approximation. So if we graph that, we say between 0, negative 1 and negative 2, so in here somewhere between negative 0 and negative 1, sorry about there. We have a y-intercept, we know that's 1. Let's put that on there. Between 0 and 1, and 2 and 3. Now if we look at the table, notice where the y values change signs. So negative 3 gives us 73, then it goes to 9, and it goes to negative 1. So it crossed the x-axis there between negative 1 and negative 2, and that's what we have. And then the next one is a positive 1 again. So between 0 and negative 1, it must have crossed again. And then between 0 and 1, it went from a positive to a negative, so it crossed the x-axis again. And then it keeps going down. Oops, nope. 2 gave us a negative 7, and 3 gives us a positive 19, so it crossed again between 2 and 3. And that's what we had written down. Very good. We can roughly graph that out if we wanted to by hand. And again, oops, I lost my graph. It was here, here, y-intercept, here, and there, I believe. Okay, and those values are based on the location principle, which says to look at the y values and see where they change from positive to negatives and vice versa. Maximum number of the maximum and minimum points. Since our vertices or our functions go on to infinity, we do not have a max or a min. We can have relative maxes or mins. So those are the little humps. We call them relative. They aren't exactly the max and the min, but they're approximate for us. And this last one I will do in part B.